problem, y is a discrete random variable. Probability mass function of y is given. Y values are from 1 to infinity. Find expected value of y and variance of y. In this video, I am going to explain how to find the expected value and the variance using the moment generating function. First, expected value of y. How do we find the expected value of y using the moment generating function? First, we need to find the moment generating function. Then, get the derivative of the moment generating function with respect to t. Finally, we plug the t equals 0, then you can have a expected value of y. Let me explain this step by step. First, moment generating function. In the previous video, I explained how to find the moment generating function. So you know already how to do this. So this is y goes from 1 to infinity, et divided by 2 power y. How do we find the sum of this part? We know this. Y goes from 0 to infinity, et over 2 power y is an infinite geometric sum with common ratio et over 2. But in our case, we have y equal 1 to infinity. So we need to make it 0 to infinity. How do we do it? I write y equals 0 to infinity, et over 2 to power y. Now you know I add one term extra. That is the term when y equals 0. When you plug y equals 0, what should be this term? Et divided by 2 power 0. That is 1. So 1 is extra. Therefore, we need to subtract 1 from this expression. Then you know infinite geometric sum. So you can find the sum and simplify, and that is et over 2 minus et. So this is the moment generating function of y. Now I need to find the first derivative of this moment generating function. So you know how to get the derivative. Using the quotient rule, you can get the derivative, which is 2et over 2 minus et to power 2. Then how do we find the expected value of y? Yes, by the definition, we need to plug t equals 0 to the first derivative. Therefore, expected value of y is 2. Now we have expected value of y. Then what is the next? I am going to explain how to find the variance of y. How do we find the variance of y? We know variance of y equal expected value of y to power 2 minus expected value of y whole power 2. We already know expected value of y, but we need to find the expected value of y to power 2. How do we find the expected value of y to power 2 using the moment generating function? We get the second derivative of the moment generating function with respect to t and plug the t equals 0. That is the expected value of y to power 2. So we can apply this. That is, we already know the first derivative of the moment generating function, which is 2et divided by 2 minus et power 2. Then we get the derivative of that part with respect to t. So again, you can use the quotient rule and get the derivative. So this is the second derivative of the moment generating function. Then how do we find the expected value of y to power 2? We plug the t equals 0 to the second derivative. That is 6. Therefore, we know expected value of y to power 2, which is 6. Now we know all the information we need. So we can use this formula, variance of y equal expected value of y to power 2 minus expected value of y whole power 2. That is 6 minus 2 to power 2, which is 2. That is the variance of y.